Hello, everyone. Thanks for coming to my talk. My name is John. I work at Wehkamp. I've been doing platform engineering for about 7 years. And I've also been doing a little bit of consultancy alongside that to keep a fresh and diverse perspective, because I do think it's important to experiment with various things. And that mostly revolves around the DevOps culture and cloud architecture, because, well, to me, that's the most fun. If you need to reach me or have feedback or comments afterwards and you can't find me around here, I usually use the same username everywhere, so it's CNCF Slack, Istio Slack, Kubernetes Slack, GitHub, whatever you can think of, usually with the same 10-year-old picture. So, let's get to it. I've made a little bit of an agenda. It's a little bit for you, so you know what to expect, a little bit for me, so I don't go off on a tangent too much. And yeah, well, let's get right to it. So, first, a little bit of context. Everyone here probably already knows what Wehkamp is. Just in case you don't, we are essentially a digital department store or e-commerce retailer or whatever you might call it. We sell a bunch of stuff to consumers. Now, this is from our corporate slide. It's probably an older one because I think the most important takeaway for us is the size and the scope of the operation. What's not in this slide is the vertical integration that we have. So we do our own software development, our own infrastructure, and our own logistics. So usually when you hear about, let's say, e-commerce, you might think about drop shipping, or you do your own buying of goods and selling of goods, but the warehouse, that's someone else's problem. Well, we, for some reason, made it our own problem, but it has paid off. It has been beneficial over the years. So if we go a little bit back in history, and don't worry, this actually is relevant. So in the corner there is a old building. That's where Wehkamp used to sell mattresses. So you want a mattress, you send a letter to Wehkamp, and Wehkamp says, here's your mattress. Pretty simple. Then we migrated to more paper, because, well, we're talking about migrations. This is your catalog with multiple products, because if you sell more than one thing, it's usually helpful to tell your people what it is that you're selling. So that's where you're essentially doing more complicated things already. At some point, you go into the very advanced age with your Rolodex and your phone, and there's even a typewriter in there somewhere. And at that point, you are kind of starting to use technology. But it doesn't really begin until this phase, where you get your mainframes, because for those who don't know, it's punch cards. It's what you use for data and programs in mainframes. Now, this is where your never-ending journey of IT migration starts, because as soon as you touch it, you're never going to be done. Whatever you buy today is going to be legacy tomorrow. Applies to us as well. I do hope Kubernetes doesn't turn to legacy tomorrow, but we'll see. And that is where the history lesson ends. But we have been migrating for, I think, about 70 years now. It's probably as old as Wehkamp is. So, let's get to the here and now. We do a bunch of stuff in AWS, including all of our Kubernetes stuff. And we have a little bit of data centers. And because we have a large distribution center, and this is an older picture, there's like 2 gray boxes in there. There's supposed to be a third one. But, well, this picture looks way cooler than the new picture. We have our own small data centers located inside of the logistics centers, because, well, we have the facilities, why not use them? So, let's go into the actual starting point of this migration. So we already had some sort of container platform, but it didn't really do the things we wanted it to do anymore. So that is something that we want to change. And to do that, I'm going to first talk about how this was supposed to work and what kind of requirements we derived from that. And it's not going to be like a long list of technical and functional requirements, but more like a short list of making the proper choices to have your new platform do things better than your old platform did. So, if we look at this very tiny picture, there somewhere in the top corner there's a developer. And imagine you're writing your software and you're like, well, my software is done, I would like to deploy it now, I want to have my service work, you know, maybe make it reachable as an API, or maybe it does other things, read messages from a queue, or talk to a database somewhere. It just does stuff. So you're like, well, I'm going to take my container and I'm going to put it into a workflow. And the workflow, in this case, will be your deployment workflow. And if you're lucky, and most of us probably are, but if you're not, it gets better, I promise, it should be automated. So from that point forward where you're saying as a developer, my software is done, I've packaged it, now let's ship it, that's where this happens. In our case, we have the container image, and the container image contains a bunch of labels. So in your Docker file, you can have a label section, you can put in all sorts of text in there. Problem is that's one big string. So in the old platform, we had a bunch of Python code that would read your container image, extract the labels as a long string, decode it into lines, and then decode it again into an ini file format, and then decode it again into YAML. which works, and at that time there wasn't anything else around, but it's not great. And then, of course, you have different environments. So what you do is you take your defaults from your Docker file and you blend it with some specific settings that we store in console. And for those who don't know, console is a key value store. It does a whole bunch of things, also like service catalogs, and you can use it for health checks and discovery. We mainly use this for key value information, for different environmental overrides. So for example, if you're Wehkamp.nl, you might do something different with your service than if it's for Cleartest.com, which is another brand of ours. So you take all of this and you end up with a bunch of JSON. And the JSON payload is essentially a big blob that should theoretically contain everything. And you give it to Marathon, and Marathon will then take care of running the application. So from a start to finish, when you get your container at one end and you're running application on the other end, in the middle sits all of this. And pretty much all of it is custom, or, well, not necessarily custom, but glued together using glue code, because there simply we didn't have any other projects or systems available that would do it for us. And this system was, I think, about 8 or 9 years old. It's been around for a while. So it makes sense that not everything that we needed existed at that time. So we had to build it ourselves. Now, it's not all bad. So the annotations might make it seem like it is super bad to do it this way. But if you look at it from an application developer perspective, it is pretty nice. Because you throw your image in one end and a working service comes out the other end. And that's essentially what you want. So behavior, or the expected functionality, is there. It's just that the magic in the middle there, that's not super great. So another aspect is traffic. So if you have a service, for example, an API or a microsite or something that talks to the big bad world, you need to get your traffic in. And that's another reason why we migrated. There's a pain point in 2 areas. So let's say you're in your browser and you put something in your shopping basket, for example. That request goes into a Cloudflare rule, and then it goes into your load balancer, and it ends up in OpenResty. And OpenResty is essentially a slightly modified version of Nginx with a bunch of Lua in there. And we use that to do things like finding out if this is URL we can actually handle, and is the method that this URL is using, or this request is using, is it allowed? Because some services would only accept GET requests or head requests, but no put or post or delete or whatever. So that's what that thing does. And then the second part is HA proxy, which is our service proxy in the old system. And it would know about all the instances of an application, but it doesn't know anything about the capabilities of the application. So it doesn't have any filtering or any URL detection or any method allow listing, none of that. So those are the 2 things that are pain points in the old system, because this is all custom. HA proxy, natively, at least until version 1.6, I think, didn't know anything about service discovery. So what we did is a bunch of glue code. You go into console, you say, hey console, what do you know about our services? And console's like, here's a bunch of JSON. And you're like, cool, we're going to translate it into a HA proxy config and reload HA proxy. And then if everything goes well, and the website doesn't go down in its entirety, your new service instances, if you deploy some, are available. So if everything goes right, from a developer endpoint point of view, your service endpoint just magically work. You deploy, you go to your endpoint, it's there, nice. If it breaks, however, none of this is really visible to a developer. And as a platform engineer, it's also not great. However, before we dive into the not great stuff, if we look at it from a developer experience, you get a bunch of nice things. So this is also what we used as an input for our Kubernetes-based replacement platform. So you get all these deployment services, your observability, you can restart and scale your application. None of it is automated, so restarts and scaling has to be done manually. And you even get a little bit of a GUI, so you can see what's happening. At least whatever Marathon tells you what's happening is not always the truth, so that's problematic. Now, if we look at it from a platform engineering perspective, you get an iceberg with all sorts of problems inside of it, because, well, as a platform engineer, you would be looking below the waterline. And it's also very expensive. So running this, I think it's like 1 or 2 orders of magnitude more expensive than doing it the Kubernetes way. And in the Kubernetes way, you also don't have all the upkeep of all the projects that you would, well, the projects you can use in Kubernetes, but you have to make them in-house and maintain them if you, well, you don't use anything that exists. So this is a very expensive and rather complicated way to do things. However, keep in mind, this is something that is more than 10 years old. Back then, you didn't really have much of a choice. You had to build it this way. So if we then go and take this, this information about what the developer experience is supposed to be like, and we take the migration requirements, which, like I said before, it's not really a functional technical requirement, but more a set of rules that you use to decide what are you going to build next, what are you going to use. And it's essentially point 1 and 2, so that's from one of the earlier slides. Developers should have the same experience, so container goes in, functional service comes out. And we also make sure that we don't make anything worse. So for example, if the old system has logging, then the new system also has to have logging. Kind of makes sense, but if you put it down in the shape of rules, then it's much easier to test if the thing you're about to build makes sense. So that brings us to our replacement platform. So the old one, it was in the corner, it was called Blaze, and the new one is called Atlas. So what did we do? Well, first we took inventory of the things that we will need to build a platform, because to migrate to something new, it has to exist first. So if we look at the infrastructure facilities, so yeah, compute, networking, stuff like that, those are not necessarily things you have to build yourself anymore. We use AWS for that. You can use a whole bunch of other providers for that. So why bother doing it yourself if there's a great service out there that does it at a pretty good price? So check, those are all good. That leaves us with runtime facilities. So your container scheduling, and spoiler, it's going to be Kubernetes, but also a delivery system, so getting something that the developer does and make sure that it actually runs and does stuff, as well as traffic management. So that's something that we also want. And we don't want to build it ourselves. So we have a bunch of icons here. Those are the things that we were partially already using in our older platform, and we're going to keep using in our new platform because they're pretty modern and they work well, and we don't have to build it all ourselves. So neat. So for the other things, container scheduling specifically, we didn't just go with Kubernetes because everyone is using it. We first checked, okay, what else is out there? What is out there that claims to do the same thing, or at least claims to solve a problem? And we tried these, and for various reasons, they just don't do the job very well. I mean, maybe our requirements are wrong, or probably not, because, well, everyone who's using our old stuff is pretty happy. So I guess it's just not the product for us. So we're not using those. Which means that you're using Kubernetes, which, well, already spoiled. However, we don't host our own control plane, because while you could, the benefit to us is pretty much zero. There's no benefit to hosting our control plane. We don't get anything out of it. It just is effort. And AWS does it really cheaply. So, like I said, AWS control plane is 2 orders of magnitude cheaper than doing it in the Mesos or Marathon way. This is like $70 a month or something, so you can calculate how expensive Mesos was to run. And that's an empty platform. Imagine how much more expensive it is when there's a bunch of services running. So that's an easy to solve problem. You do have to make sure that you go on an expedition and find out that the thing that you're choosing is the sensible choice. But after you've done that, with clear conscience, say Kubernetes was the right choice. Because there's always people who are going to say, well, Kubernetes is very complicated and you have to spend a lot of time on it. And, well, that goes for most things. So, that means that for the other things, so the traffic management and the deployment systems, there are a bunch of ways you can go about it. Watch videos, read blogs, and just try stuff out. One of the very common ways is to go to the CNCF landscape. Of course, if you go to the landscape the first time, you're like, what the hell is this? There are a billion things here, and I have no idea what to do with this. However, if you focus a bit and filter stuff out, you have, in our case, because we're looking at delivery and we're looking at traffic management, you have these areas to look at. And if you filter these areas out a little bit more, for example, projects that haven't been proven in production anywhere, or maybe things that are very expensive. So, because for us, the balance between cost and effort is, we do have the people, but we don't have a very big budget to let someone else do it. So we often have to make the choice to do it ourselves and then find something that can be operationalized with ease. But for us, it means that we take all of this and we filter it down to stuff that we can run, stuff that we can think, well, we can learn, and stuff that other people have already proven that actually works. So you pick the projects, you go through this loop a couple of times, and at some point you will find out these are the products I'm comfortable with, or the products that I know I can make work. And you do need a little bit of time and freedom to do this. If you don't have the time or freedom to do this, it's much harder. But I do think this yields the best results, but it's different for everyone. For us, that meant delivery system, ArgoCD. For those who don't know, Argo, I think, came from Intuit, the American tax company. And they have a whole bunch of projects like ArgoCD and Argo Events and Argo this, that, and the other. But they're very nice projects. They solve a problem and they solve it well. Same goes for Helm. We did have a choice between, for us at least, Customize and Helm, because they both do the job well. We chose Helm because it does look a little bit more like a package and a little bit less like a collection of individual files. And we chose Istio for our traffic management, not necessarily because it is the only option out there. We also looked at Linkerd, and there are a couple of managed service meshes. But when we looked at our traffic, so the Lua thing in the OpenResty part that I mentioned earlier, and the JProxy thing, while their work isn't necessarily very complicated, one of the problems that we have is you can't do any blue-green deployments or any traffic shifting or circuit breaking, stuff like that. So when you want those things, then the Nginx ingress controller, for example, is also not going to give you that. So in our case, Istio was the best fit. We also did look at Linkerd a little bit, but Linkerd, like some other things, it requires you to stack some stuff on top of it to get the functionality out of it that you want. So that is, in a nutshell, the choices that we made to get to a working configuration for a new platform. Now, that's not the only thing that we did. So you can take these things and manually install it into a cluster and then call it a day. But that means that if your cluster breaks, then you have nothing. You have to do all of it over again. So you automate all of this, and we did that using a Christmas tree. So we have a bunch of clusters, and this is just a snapshot. We have about 20 or so. And what we do is we have one cluster, and it's called a controlling cluster. And what that does is, and these are all these boxes, they are a separate AWS account with a separate VPC, so that's a virtual network, and a separate Kubernetes cluster, which means that if there's any damage or any problems, your blast radius is very much contained. And because they are all essentially deployed on the infrastructure side using Terraform, it's automated. So it's almost like a zero-effort rollout of your clusters. If you want one cluster or 10 clusters, it's the same effort. So that's pretty neat. So the top one, that's our global ArgoCD. So what that does is it configures other ArgoCDs. So that means that if you add or remove an ArgoCD, you don't have to do any work. It just, as long as your cluster is tagged correctly and it shared a token with the upstream ArgoCD, it'll configure itself, which is pretty neat because all of this stuff is stateless. And that doesn't mean that it has no internal state, but it means that the configuration and how it works is all stored in Git. So one of the things that we did immediately was like, we don't have the time to debug everything manually, and we don't have the time to dive into every problem, so let's go with GitOps and make sure that whatever happens, we'll just go revisions forward and backward instead of manually trying to edit stuff. It's just, we don't have the manpower to do that. So the main Argo at the top, it only does the lower level Argos, and those have a specific job. They assign workloads. So if you're a developer and you're targeting Wehkamp, for example, your workload would be read by the Wehkamp Argo, and it would find out what it is that you want. Say you want a prod instance and a dev instance, or you want 50 prod instances and 2 dev instances. That's what it does. But it doesn't run the workload itself, so it delegates all that workload work to yet another cluster. And those runtime clusters, they can be swapped in and out at will, essentially. And it's not entirely true because the CAs that you use for your tokens and for your identity, that would of course be unique per cluster. So if you rotate those out, you also have to tell your resources like, hey, there's this new cluster with this new identity and it would like to use your resources. It's a whole mess. But if there's ever a defect, or if there's a human error or anything happens, you can replace each of these components without disturbing anything else. And the nice thing about ArgoCD is it controls your resources in Kubernetes, but it doesn't mean that if ArgoCD stops working, your resources disappear. They just stay in there, which is pretty cool. So a group of those, let's say these runtimes, these controls together, that's essentially an organizational unit within AWS. You can also call it a AWS namespace, if you will. That one is, say, not necessarily a singular blast radius, but it would be responsible for a single brand in this case. So our affiliate domains are separated by brand at this time. We are switching that around a little bit, but this model allows you to slice and dice your blast radius in whatever way you want, because you can deploy more groups or fewer groups without having to change the configuration internals of Kubernetes or ArgoCD or AWS. So that brings us to the actual migration, which is, well, if you have already built a platform, this is the hard part. So what we do is, and we take it a little step lower, so I mentioned Marathon earlier, but Marathon itself doesn't execute your tasks. That's the job of Mesos, which is another Apache Foundation project. And a little side note, Marathon and Mesos, they were both almost sent to the attic, which is Apache Foundation parlance for we're going to nuke this project. No more patches, no more security. So yeah, that was problematic for us. But what we want to do is do it live. So no weeks of downtime and no big bang deployment where everyone has to do it at the same time. And we also didn't want to do any code rewrites. So imagine this OpenResty thing again. It was also responsible for authentication. So it would validate your JSON web tokens or hand out anonymous tokens if you're not logged in, tasks like that. And you could say, well, on a new platform, every service has to do it themselves. That wouldn't be very nice, because now every developer has to redevelop their middlewares in their services to do the authentication. So that was one of the rules, no rewrites during the migration. You can do it afterwards if you want. And the behavior should be similar enough. So if your service is on the old system, the Blaze platform with Mesos Marathon, it behaves a certain way. It should behave the same way on Kubernetes. And with Mesos, that is relatively easy because it doesn't have any real custom behavior. Mesos is essentially just running Docker containers. So it doesn't really do anything special that Kubernetes couldn't do. So if we go and look at what this involves as you have your Docker file and you are a developer, as you transplant your service from one place to another, you do have to change your configuration style a little bit. So like I mentioned before, you have this Docker label. It's a big string of text, and it contains an ini style configuration set. And you can do all sorts of things with this. So in this case, it's mostly about the amount of instances you have and your traffic ingress. But it also does things like CPU and memory and how many instances you should have at the maximum, stuff like that. So that one has to be transplanted. This is your default in your Docker file. There's a YAML variation of the same information, and that one will be in a YAML file in a different repository from your application code, and that will be put into console. So if you remember the shoot with the deployment thing, that's where console will put this. This thing will be decoded, and then the YAML thing will be decoded, and will be both put into the same JSON blob. Now, that is a custom system, and it's also a little bit of a pain, because as a developer, you now have to look in 3 or 4 different places for your application configuration. It's not very nice. So with Argo comes the application and the application set. So an application is a resource in Argo that defines a desired state for a bunch of manifests. It doesn't actually do the application itself, even though it is called an application. And you can create a set of those, and that's an application set. So what an application set does is you have your generators configuration spec, where you say, I have a bunch of environments that I know about, and then Argo can fill in the bottom part, where I have a couple of clusters that I know about, and it multiplies them by each other. So for example, it can take your environment values for a development environment, and it takes all the clusters it knows about and it multiplies them with the configuration that's set in your environment value. So in this case, for example, if you have 2 dev clusters and 2 prod clusters, and they're prefixed with WL because that means workload, it's very creative. But your dev clusters will both have the replica count set to 1, and your prod clusters would be both set to 2. Makes sense, right? And if we on the platform side would add 10 more clusters, then this would just rerun and do the whole thing, but instead of doing it 4 times, it would do it 14 times. So it's a pretty neat way of automating things, and instead of looking at 10 different places, you would look at in one place. So that's a really neat improvement for developers. But you do, of course, need to transfer your configuration. Now, there's a little bit of additional configuration. So the application set, or the application, I would say, it can call individual manifests. So you can point it to a Git repository and say, take this manifest and generate an application based on that. You can do the same thing with Helm charts or Customize, or I think it even supports JSONnet and KSONnet and a whole bunch of other formats. We used Helm. And some of the values that you can enter into a chart will influence how your application receives its traffic. So this is in the same file as the application set I just showed. And just like in the labels, you can say, well, my service is for internal use only, so I'll enable trusted, but I'll disable everything else. Or maybe my service is for public use, and I enable consumer. So that's your configuration done as well. So from a developer's perspective, you get the same behavior and the same features. So that's pretty neat. It's just shaped slightly differently. If we look at what this does from a JProxy and OpenResty side of things, so the custom stuff that we had in Blaze, we don't have that anymore, so we replaced that. And if you remember, we used Istio as our choice for traffic management. In Istio, you can use a resource, and in this manifest it's listed as the authorization policy, and you can configure what type of traffic your application supports. In this case, we scoped it to HTTP methods, and we said, if there's any traffic coming in from the outside over the consumer gateway, so that's what this principles thing means. This is a so-called spiffy identity. This means that your traffic that comes into your service, if it detects this is the principal and these are the operations, in this case put, post, and delete, then it will be denied. So the same features that were available in OpenResty are now also available on the new platform. So everyone happy, developers get the same features, we don't have to maintain our own gateways, and it's happy days for everyone. So that is your service configuration migrated, but that's not your traffic migrated, because you can run all of this, but if your visitors don't arrive here, then it doesn't matter what you're running. So that means that we actually have to migrate the live traffic as well. So the icons and the text here is a little bit wrong. This is supposed to be Blaze, the old platform, and the old platform doesn't have a concept of pods and services and ingress, but let's ignore that. You have your load balancer, and your customers enter in your load balancer. So what you could do is do a big bang migration. You have a moment where everyone has to migrate at the same time, you switch the load balancer over, and it should be okay. That's, however, not realistic. So we have about roughly 100 people in our tech department, and having everyone aligned at the same time, at the same skill level, doing the same activity, that's asking for trouble. And we also just didn't want to. So what we did is we took our new system, we put it next to the old system, and we said, dear new system, if you ever receive a URL or a request you don't understand, just send it to the old system. Problem solved. And then the next step was, just move the ALB around. Because with this configuration, your services didn't need to be migrated, but your traffic flow can just cross over to the old system if a service hasn't been migrated yet. So in this scenario, there are 0 services migrated. So that means that if you, for example, take the basket, for example, again, you put something in your basket, the new platform says, well, I don't have any basket, I don't know what to do with this. It just forwards the traffic back into the old system, and the old system still has your basket. Everything goes well. So this way, you can then piecemeal take each individual service and migrate it over. So if you now take your basket from the old system and put it in the new system now knows about your basket. And then the next time a basket request comes in, it knows how to deal with it. So this all went reasonably well. Some of our development teams, they went crazy on this and migrated everything in a couple of days. Others needed a little bit more, let's say, persuasion and influence on their planning. We did have some swarm event at some point where we said, okay, you all had a year to migrate. If you're not done yet, this is the time where you're going to do it, because you're not allowed to do anything else anymore. Because if you give someone a year to just make their own planning and it still doesn't work, you're probably going to need to intervene a little bit. So it worked. It ended up working really well, new platform. We saved a bunch of money. We had lots of custom stuff that turned out, if you look at the CNCF landscape, were already implemented by other projects. So, for example, KEDA for scaling, which is a very nice system to have your GitOps cake and eat it too, because your GitOps doesn't know about your scaling, but you can say you have a limit at the top and a limit and a floor at the bottom, and you can then use KEDA to decide how you want to scale. Same goes for Carpenter. You can use your cluster autoscaler, but it is a little bit slow, and Carpenter is super fast. If you want to have 1,000 nodes, you'll have it in 10 seconds. So there are a lot of nice projects that solve individual problems very well, and learning a little bit about those, experimenting a bit, going through the cycle where I just mess around and find out. For us, it worked out really well. So that's it. Thank you for listening.